So this is the Pyrotron.
This is the Pyrotron, shiniest wind tunnel in the world. 25 metres long. There's a working section that's 4.8 metres long. It's 2 metres by 2 metre internal dimension. At that end of the tunnel we've got a 2-tonne fan that will shift 22,000 litres of air a second. Most of the tunnels actually designed for removing as much of the turbulence out of the airflow as possible, so that when the wind finally gets to where the fire is, it's as smooth as we can make it. Any resulting turbulence is then a result of the interaction between the fire and the airflow. We have instrumentation in there at the moment in the form of thermocouples. We can add in lots of other different sorts of instrumentation. There's 2D sonic anemometer and a pitot tube for measuring airspeed.
What are these called, sorry? These
2D sonic anemometer and a pitot tube is the little L-shaped doodad. These will all get connected to the data acquisition system and the computer, which would sit here in the command console.
Yeah.
That's inside the office at the moment.
And what kind of fuels would you put here normally? Would it vary or?
Yeah, it can vary. Basically, we're looking at fire spread through what we call surface fuels.
Okay.
So that's either forest litter for forest fuels or grass.
Yeah.
We actually finished part of, well, the first part of the experiment that we're doing for Victoria in the field, we did that here.
Right.
We actually grew our own grass and conducted experiments here, and then moved into the field side of things. So surface fuels basically. Because of the height of the roof, we're limited to not getting flames greater than say 700 mil.
Okay.
Because taller flames will have a plume that then interacts with the roof.
Right.
So we don't want that. Yeah. So.
But this back hatch opens up.
Oh yeah, the door opens up and it's got a
yeah. And we've got a little tunnel that sticks onto it here. Oh yeah, that'd be good. So this is the back of the Pyrotron out here.
So this, when we're running an experiment, we open the door, roll that in, bolt it up, and then all the smoke and stuff comes out here.
Right.
Stainless steel mesh to try to stop embers and things from falling.
Okay, yeah. I don't want to start any bushfires out here.
No, particularly the whole intent of something like this is to be able to study fire behaviour under the really extreme fire weather conditions.
Right.
Which we're not allowed to study in the field.
Yes.
So we have permission from local rural fire service to actually run experiments on what we call total fireban days. So there will be smoke coming out, and we had a sort of a public campaign to try to inform the residents that aren't too far away that any smoke they see on a total fireban
don't worry
day
about it. Yes.
Something to worry about unless it keeps going.
Yeah.
Because an experiment won't last for more than 15 minutes.
Okay. And what sort of temperatures and wind speeds will you look at typically?
Maximum wind speed we can get in here is about 5.5 metres per second, which, if you consider that's at the level of the fuel, and you're looking at the equivalent of, say, a forest, that's about the same as 60 kilometres an hour in the open.
Right.
Which is quite high.
Fast.
Yeah.
Yes. Great.
Temperature, in terms of air temperature, we can light under any air temperature condition. We've also got the ability to dry artificially the fuels so that we can replicate really dry, really humid conditions that you'd normally get with wildfires. Yeah. Because quite often, as with today, the days that you actually want to do your burns, they're not the best days for doing experiments. So we can artificially modify the fuels to a certain extent to try to get the information that we need.
Great. Lovely. Thanks.